This is an animation that folks at Northrop Grumman put together showing the sequence of events. Once we get released by the upper stage from the Ariane, we go through a series of maneuvers and deployments. You can see on the top the time after launch, the distance will come up with the activity, and you can see a little graph showing where we are in our journey. The solar array comes out very quickly, so we have power. We start to do any course corrections we need to make sure we're going to the right orbit out there at L2. The smaller the correction we have to make, the longer our life is because it saves fuel. Right about the time we get close to the moon, our high-gain antenna comes out so we can communicate at a high data rate. You can see about 2 days we're past the moon. Now we begin the major deployments where what's called a pallet that holds the Sunshield, the forward part folds down. We'll follow that by folding the back part down. I got to watch them test this at Northrop Grumman. They do a gravity offload to test the system. Now, once those are down, we want to move the telescope away from the spacecraft because it is a little warm itself, so we telescope up on a tower about 5 feet. Now, the covers that protected the Sunshield during launch are released and they roll back. Some covers in near the spacecraft core do the same thing. And once those are released, we can actually begin to push out concentric tube telescope booms to extend the Sunshield. There are 5 layers to this Sunshield, and it's critical that there be separation in these layers so that heat from one layer can escape out before it hits the next. So they'll tension up the system, which is just a pulley system that raises the layers apart and provides tension to them. The next deployment is a flap in the back that you can think of as a sail because it's there to balance the solar photon pressure that would tip the telescope over if that were not there to balance. The center of pressure and the center of mass aren't exactly the same.
That's ridiculously cool.
That's the cryocooler starting for that mid-infrared instrument, a little refrigerator to keep it super cold. And here, after about 10 days or so, the secondary mirror comes out, and it's at this point when light can actually, focused light can get into the science instruments. There are a lot of radiators that get deployed during this sequence. And then we bring drop leaf table style, the 2 wings come out. So after about 2 weeks, the major, I call them visible deployments, are done. But then the mirrors themselves are held down to that backplane structure for launch. They get released, and we begin to start moving those as they're cooling down and begin to bring them into shape. It takes about a month for us to get out to L2. We're cooling down this whole time, starting to commission the instruments. We're a little bit like a planetary mission in that we'll launch, fire and smoke, a lot of activity. The first data don't come out until 6 months after that. So after the launch, if you don't hear anything for 6 months, It's okay. Well, we actually, that's a big activity we have now, is how do we bring along, the public, the taxpayer, with all the activities that are going on, even though we're not seeing data yet.
Well, those first 2 weeks, will we be able to follow along live with each and every deployment?
Yes, that's going to be a big part of, again, bringing people along for the ride. Is we have social media accounts describing, this is what's going to happen today, and here's how we know that happens. We don't have any pictures, and there's nothing that will be taking a picture of us while we're out there, but we'll have great computer simulations showing the state of the spacecraft. So once we get out there, what in fact will Webb do? So we know already that it will be looking for these first galaxies. And here you see an enormous simulation of the universe with dark matter in the purple, where visible matter is accreting at the dark matter centers and galaxies are beginning to form. This is the reason we built Webb. We know this is the science it's going to be able to return for us. So that's certainly exciting. The other thing that has become, I think, maybe even more exciting for a lot of people is this notion of exoplanets. As I mentioned, when we first conceived Webb, we didn't think we were going to be doing exoplanets because we only knew of 2. Well, now we know of thousands. And the way Webb will really contribute is in the cases where you have a transiting exoplanet, an exoplanet that goes between us and the star, and we will look to see if that planet has an atmosphere that subtracts certain elements of starlight from it. So we are really going to be looking for habitable atmospheres with Webb. It's got the mirror size needed to do this. It will still be challenging for Webb, but it will be the first telescope that you'll really be able to go after this in a very big way. And so this is something that we already know is going to be a big focus for Webb, even though when we built it, it wasn't conceived that we would be doing that. The infrared capabilities of Webb will allow us to peer inside the birthplaces of stars and planets within our own galaxy. And we already have seen there are programs, I'll talk a bit about more of those in a second, where people are going to be doing just this. So another way to watch star birth in our own galaxy. Even though it's a big telescope designed to look at the distant universe, it will be able to do amazing things within our own solar system. Now, because of the configuration, we can't look at the inner solar system. So we can't look at Venus, we can't look at Mercury, can't look at the Earth. We can look at Mars. You can do weather, global weather on Mars by looking at it with Webb. I really think most of the time will be spent on looking at the large moons in the outer solar system and the trans-Neptunian or Kuiper belt objects. Again, with the infrared capabilities, it's a great thing to study those. A lot of words up here. The main thing is the link at the bottom. We already know some of the first things Webb is going to look at, and these are the so-called early release science programs. These were competitively selected, and they range from distant universe observations to looking at bodies within our own solar system here. So already the community knows what they want to do for the first things that Webb is going to look at. And if you want to follow along, like every person and or spacecraft these days, it has a Facebook page and a Twitter account. And
is it going to talk in the first person like, oh, I stretched my wings
today? Actually, a bunch of us don't want it to do that.
I know, exactly. I was like, oh, please.
Yeah. So,
it sure is cold out here.
Yeah. I can already see the bad jokes. They won't be from me, I'll tell you that. The top link there is the main one, and NASA has a lot of, you can get to a lot of hardware images and movies and whatnot, and the one below it, the webtelescope.org, is the one that the Space Telescope Science Institute runs, and that's going to be focused more on the science that comes out. So that's a little bit, it doesn't have as much on it right now because we haven't done any observations yet. But I'm looking forward to the launch in March of 2021, 6 months after that. the amazing science will start coming out. And so, keep on the lookout for those, and I would be happy to take any questions you have about Webb now.